Welcome to this video lecture series on antenna and wave propagation. In this video, we are going to discuss rhombic antenna as suggested by one of you only. Rhombic antenna is a very important antenna. So, we'll begin with a very important information about rhombic antenna, and after that, we'll discuss its structure, designing, and after that, we'll discuss its advantages and disadvantages also. So first we'll begin with the important information. So the important information is that the rhombic antenna was discovered during World War II. So I hope you must be knowing about World War II. During World War II, there was a grouping of countries. So there were two grouping of countries. I hope you must be knowing. In both of the grouping, some countries were there. So these countries needed to contact each other when the war was happening. So the countries in a particular group needed to contact another countries in that group. Similarly, countries in another group needed to contact all of their friendly countries. So for that they needed an antenna which is having high gain in a particular direction. So at that time, point-to-point communication was really required. So for that, the research in antenna designing was happening at a tremendous pace. So antennas discovered that time only. Similarly, the rhombic antenna also discovered that time only. And before World War II, it was used as a point-to-point communication antenna. But after World War II, it started getting used as short-wave broadcasting antenna. So starting with the basic structure of rhombic antenna. Rhombic antenna is a word which is derived from the word rhombus. I hope you all must be knowing about a rhombus. Rhombus is a structure which is having four sides. So the four sides are equal in length. So first I'll tell you about the rhombus. Rhombus has four sides which are equal in length plus the four angles it has which are made by the four sides which may or may not be equal. But the opposite angles are always equal. So this is the basic property of a rhombus. So a rhombus is a structure which is having four sides which are equal in length, and the angles are not necessarily equal, but this is a star point which is opposite angles are equal. So in rhombus, I hope you can imagine the structure. The rhombus looks like this. So all the sides are of length L. So these are four angles. The angle 1 is not equal to angle 2. So this is the property of a rhombus. So now coming to rhombic antenna. So rhombic antenna, this word is derived from the rhombus only. So the structure of rhombic antenna is similar to the structure of rhombus. So I hope now you must be imagining the structure of the rhombic antenna. So I must tell you it is a high frequency antenna. So rhombic antenna is a high frequency broadband antenna. So if I draw its structure, so this is the structure of a rhombic antenna. So this is my feed point. So after the feed point, the wires are in the form of a rhombus. So this part of transmitting cable is tilted with an angle theta naught, and the lower part of the transmitting cable is also tilted with the angle theta naught, and again this is tilted with some angle which is not equal to theta naught. So now at the end there is a load resistance as well. So this is my load resistance. So if you see this structure, you must be seeing this structure is similar to the V antenna. So I hope you must be remembering V antenna. So this part, so this upside part is the tilted V antenna. This part is the V antenna. So I hope you remember the V antenna. If you don't remember, you can go to my previous video, you can watch that video and you can come back. So this is V antenna, this is tilted V antenna. So it's a combination of two V antennas. So you can see, you can imagine that how I am saying it is a combination of two V antennas. If I cover this part, it's a V antenna. If I cover this part, it's also a V antenna. Similarly, I can say it's a combination of four linear antennas. So it's a combination of four long wire antennas. So this is a long wire antenna, this is also a long wire antenna, this is also a long wire antenna, this is also a long wire antenna. We can imagine it as a combination of four long wire antennas. So now there is a load resistance which is of the order. So the load resistance has the value 600 to 800 ohms. So why we have connected load resistance? Load resistance is connected to remove the effect of reflection. I hope you remember, whenever I have a long wire antenna which is not connected by load resistance, what happens? The current comes and it is reflected back with, why? Because there is an abrupt end. So here it's a connecting wire. So if it's a long wire, so here it's a conducting wire, after that the air, which is insulator. So whenever current comes, it encounters an abrupt change in the conduction which makes the current to return back, and this is called reflection. So to avoid this reflection of current, I have load resistance connected here. So there is this load resistance which is removing my reflections. So whenever load resistance is not there, we can have a rhombus antenna without load resistance as well. So what happens in that case? In that case, I have reflected current as well. So let's understand this with the help of the radiation pattern. So let's understand, this is my rhombic antenna. So now I am taking the case when it is not connected with the load resistance. So here my load resistance is not present. So this is my long wire antenna. I hope you must be remembering the radiation pattern of long wire antenna. So it looked like this. Similarly, the radiation pattern of long wire antenna, this looked like this. Because it is non-terminating, it has major lobe in front and as well the back side as well. So what happens? All of the radiation pattern, it is in this direction, it is in this direction, it is in this direction, it is in this direction. So all of them will get added up and I'll get a radiation pattern like this. So it's a bidirectional radiation pattern. So whenever load resistance is not present, I'll get a bidirectional radiation pattern. So I hope now you understand why load resistance is present. I don't require the radiations in the back side. Why? Because if I am communicating to a person, the person is in the front side only. I don't require the radiation to come back to me as well. So this is the radiation pattern of rhombic antenna which is non-terminated by any load resistance. So here we don't have any load resistance. The radiation pattern is bidirectional in nature, but the radiation pattern is not perfectly bidirectional. Why? Because there are various losses which are occurring in the long wire antennas. So the coupling, the losses, all them combined up, and the radiation pattern is not perfectly bidirectional. Therefore, we cannot use the rhombic antenna without the load resistance. So now we have the radiation pattern of rhombic antenna when it is connected to the load resistance, which is used predominantly. So now we'll see the radiation pattern of the rhombic antenna when it is connected by the load resistance. So now this is my rhombic antenna. So if I see the radiation pattern of this long wire antenna, so it is connected by load resistance, which means it has radiation in the forward direction only, and there are only minor lobes in the backward direction. Similarly, this is a long wire antenna. Similarly, it has the radiation in the forward direction and minor lobes in backward direction. Similarly, for these two long wire antennas. Now again, I'll combine the radiation patterns. The radiation patterns in all the four directions will combine up, and I'll get a massive radiation pattern in the front direction and some minor lobes. And this is my massive major lobe. So because of the huge directional property and huge gain, so the gain is enough because all of the major lobes combine in the front direction. So I'll get a huge major lobe in the front direction. So this is how I'll get the radiation pattern of a rhombic antenna. So now there is another case when the ground is present near the rhombic antenna. So this is the ground. Let's suppose this is the height of the rhombic antenna, HM. I am taking it as the minimum height. So now this is my minimum height, and I am supposing my rhombic antenna is very close to the ground. So whenever my rhombic antenna is very close to the ground, at that time the radiation pattern would change due to the effect of ground on the rhombic antenna. So the changed radiation pattern would be somewhat like this. So the radiation pattern which was parallel to the ground surface, it's now tilted. So now, because of the ground surface present nearby the rhombic antenna, the radiation pattern is tilted in some direction. So to design this rhombic antenna with a particular height and a particular tilt angle, so I am taking tilt angle to be psi. So this I am taking to be psi. So this is my psi is my tilt angle. HM is the minimum height above ground. So theta naught is the angle. So 2 theta naught is called the apex angle. So we need to design our rhombic antenna. So for designing, I need to know the theta naught. Theta naught is my apex angle which is used to design the rhombic antenna. Plus I need to know the psi, the tilt angle. Tilt angle I can decide according to my target. So whichever country I need to send my signal, I know that which direction I need to send my signal. So psi I know. After that I should know HM and theta naught. So we'll derive these things with the help of this psi. So this psi can help me to find out theta naught and HM. So we'll see the basic relations of all these things. So this relation is HM upon lambda. Lambda is the wavelength of the EM wave. So whatever frequency I know I have to operate my rhombic antenna, with the help of that frequency I can find out lambda. So I can find out lambda. I can choose m. For m is equal to 1, I can find out various HM and psi. So I have another relation also. So the second thing I need is L. So I need to know what is the length of my rhombic antenna. Generally the length of the rhombic antenna, this is L. So here I am denoting it with capital L. So the length is 1 lambda or greater than it. So generally I take the length in the order of lambda, which is 1 lambda, 2 lambda, but I need to know exactly what is L. So to find out L, I have this formula. So L upon lambda is equal to 0.371 1 minus sine 90 minus I cos theta naught. So for HM, I'll use this formula. HM upon lambda is equal to m upon 4 cos 90 minus psi. I'll use m is equal to 1 and I'll find out HM, where psi is my tilt angle. So now here theta is my apex angle. So with the help of all these things, and we can find out theta also. So theta naught is equal to cos inverse sine 90 minus psi. So now, so there are two types of rhombic antenna. I can have serial connection and I can have parallel connection. So in serial connection, this is my feed point, this is my first rhombic antenna, it is connected to the second rhombic antenna, third rhombic antenna, and so on. After that it is connected to the load resistance. This is my feed. In my parallel connection, what happens? This is my feed, this is my rhombic antenna, this is my load resistance. Now it is connected parallelly. So it has another rhombic antenna which is connected to the another load resistance. Similarly, it has another rhombic antenna which is connected to another load resistance. I can even extend the number of antennas in serial as well as parallel connection. So I hope you remember in my array section I told you why I use array, to make the radiation beam narrower and to make it more intense. So this is why I am connecting the rhombic antenna in serial as well as parallel fashion, but there are some limitation and advantages. So if I connect the rhombic antenna in serial fashion, I just have one load resistance. So I just have one load resistance, which implies the power loss is less. But you can see it is taking a large space. But if I see the parallel connection, in the parallel connection what I can see, it is taking less space. So this is the advantage of parallel connection, but it has 3 load resistance for an array of 3. So which means the power loss would be more. So whenever I have more load resistance at the load, I know the power is dissipating. The power dissipating is resulting in the energy loss. So efficiency is less in this case, but efficiency is more in this case. But it is taking more space, and I hope you know that space is a serious issue whenever I design antenna. So I need the antenna to be as compact as it can. So I hope now you know the advantages and disadvantages of both of them. So now in general we'll discuss various advantages and disadvantages of rhombic antenna. So the very important advantage is that it is very simple and it is very cheap. So it is very important advantage as anyone can design it, and there is no specialization which is required to design this rhombic antenna. After that, I told you some of these radiation patterns are giving me a radiation pattern which is having huge major lobe. So it is having high forward gain. So I can say whenever these radiation pattern with small forward gain combine, so four radiation pattern with small forward gain are combining to give me the radiation pattern which is having extremely high radiation pattern of major lobe. So it is having very large major lobe, so high forward gain in this case. So the next advantage is that it has wide bandwidth. So because of wide bandwidth, it can be used for a large number of frequencies. So it can be used at frequencies, a lot of frequencies, which means it has a wide bandwidth, and because it has high forward gain, it can be used for long distance communication in a particular direction. As I told you, in World War II, it was used to communicate in 2 countries. So it has high forward gain, which is implying it has high directional properties, which is making it to use as point-to-point communication between long distances. So now we'll see the disadvantages. So the first disadvantage is space. So I was telling you about space here as well. It is taking a lot of space, which makes it unsuitable to use when I require my device to be very compact. So I need a device which I can carry with my hands. So I cannot carry a larger device with my hands. So space is the real issue. After that, it has efficiency issue. So why this efficiency issue? Because a lot of power waste at load resistance. So efficiency is around 40 to 50%, which is very less because a lot of power is wasting at RL. So here power is wasting, which is reducing the efficiency. So now the last disadvantage is, so the presence of minor lobes. Here I showed there is some minor lobes as well. So the presence of minor lobes is decreasing the accuracy of this rhombic antenna. So I have some radiation in the backward or sideward direction as well. So this is reducing the efficiency of my rhombic antenna. So I hope you understood various things about rhombic antenna. I'll stop my discussion here, and if you like it, share it with your friends and also push the like and subscribe button. Thank you.